I wouldn't consider these notes. I would consider more like these overview. So they're not notes. Like you're not supposed to like, oh, what? I'm not following along what he's doing. That's because I'm just flat out just going to the answer. Does that make sense, guys? Now, if you guys feel like I don't understand any of this, then let me know and I can revert back and start doing like some legit notes. Cool? All right. So I have an expression here. Did you already got a copy, miss? Here you go. Oh.
Thank you.
I got an expression here. It says the fifth root of x squared. And it wants me to write it in exponential form. So how do I write that in exponential form? You do it like this. You go x to the 2 fifth. Where the 2 is the squared, that's from x squared. And the fifth, the denominator is the fifth root.
You're all yours, Tom.
Awesome. Thank you, Downs. Does that make sense, guys? Now, really quick, I want you guys to know something. If I were to have... what does this mean, the third root of something? That means that they want a multiple that repeats 3 times, right? So if I have something like, I'm just going to make this up. I'm going to put happy face to the third power. Well, that would give me happy face. Why? Because happy face to the third power means happy face, happy face, happy face. And as soon as you have a group of 3, you take it out. It's a single. Does that make sense? So if I tell you cube root of 8, well, this is the same thing as 2 times 2 times 2. Notice there's 3 of them, so 2. If I tell you fourth root of 8, fourth root of 16, because I'm thinking of perfect numbers. Well, that's 2 times 2 times 2 times 2 times 2. Did I give a 2 too much? 2 times 2 times 2 times 2. 4 times. So that would be 2 as well. Do you see how that works, guys? Okay, just making sure. All right, so check it out. Write the expression 6th root of x to the 5th in exponential form. So how does that look? X to the 5 over 6. 5 6. It really is that simple, guys. So that's why some of it you're going to destroy really quick. Are we cool there? All right. So now let's see if we can do some of these. So these are just from your rules from back in the day. I think when you guys had Torres and Luna, was Luna your Algebra 1 teacher or was it Torres? Torres? Yeah, she probably gave you one where it's like x times to the power m times x to the power n. And what do? You add the exponents. Do you remember that foldable or that activity? So it's the same deal here, guys. I have x to the 1/3 times x to the half. So I want to know what this exponent is, that a there. And believe it or not, this is a very common ACT, SAT question. So all you're going to do is x to the 1/3 plus 1/2. If you have a calculator and you want to add those exponents up, that's fine. But I would like for you guys to be able to do that like without a calculator, right? Common denominator, so times 2 over 2 times 3 over 3. So it looks like you're going to get x to the 3, 4, 5 over 6. And there it is, x to the 5, 6. If someone tells you that they want this with a radical, so then that's the same thing as saying x to the 5th and then the 6th root. They're all related. Do you see how we're doing this, guys? By the way, the root and the power have the same weight, so it is okay, not conventional, but it's okay to do that. Okay, and I'm going to put an awkward emoji. It's not conventional, but I have seen some textbooks do that, and that's okay because they carry the same weight. You'll get the same answer. Cool or not cool? Cool. All right, let's keep going. So look, it's just another example, but this time instead of a product, it's a quotient. Quotient is just a fancy word for division. So whenever you do that, whenever you had, I'm thinking of Algebra 1, when you had Ms. Torres, she probably told you to do this, m minus n. You guys remember that? So it's the same deal. We're doing the same thing. So x to the a, it's going to be x to the 3 minus 5/3, and that's an exponent there. Chavez, I need to do common denominator. Yeah. I mean, you can use a calculator, but try not to. Multiply that 3 by 3 over 3. So then that becomes 9 over 3. See, 9 over 3 is still 3. And then you get x to the 9 minus 5. 4 over 3. See? Pretty easy, right, guys? If you wanted to simplify this, this is done. Like, that's what your A is. So when you get this question in simplest form, this is your answer. But remember what that means. That means third root of x to the fourth. And really, if they wanted you to really simplify, x times x times x times x, grab 3 of those dudes, and that would be x cube root of x. So this is the best answer, but they don't always, well, it's the best answer in terms of radicals. X to the 4/3 is perfectly fine. Cool or not cool? Are we learning, or is this all like stuff that you already knew, or is that some of it kind of new and kind of, okay. Oh, you're not learning? All right, so check it out. This is very common. On the ACT, they give you harder ones, but it's the same deal. So I have z divided by z to the negative 6. Usually, you want to turn it into positive exponents, guys. So side note, 1 over z to the negative 6 is the same thing as z to the 6. Do we have questions on that? Like, are you guys sold with that? Like, you guys got that for sure? What's up? No, no. I did this. So remember what Torres told you guys. So if I had x to the 5th over x to the 3rd, wasn't that just x squared? Because you did 5 minus 3, right? So what if I had x to the 3rd over x to the 5th? Well, that means, let me erase some of this over here. So let me expand it, guys. So I don't want to do a lesson, but that's okay. X times x times x over x times x times x times x times x. You're going to get 3 of them that are going to cancel out. 1, 2, 3. How many do you have left? 2, but in the bottom, right? So notice you can either write it like this if you want to have positive exponents, or you can write it like so. Because what is 3 minus 5? Negative 2. So do you see how these two are equivalent? So it's the same deal. So going back to my side note, 1 over z to the negative 6. If I want to turn that negative 6 positive, it's the same concept. Bring it up. Z to the 6. Do you guys see that? Cool. So now that you guys see that, the first thing I would do is evaluate the inside. So if I bring it up, here's what you have. Z times z to the 6. All raised to the 1 over 28. Are we still okay? The next thing I would do, what is z times z to the 6? Perfect. Z to the 7th. And I still have that 1 over 28 right here on the side. Where's the what? Oh, well, this is the power 1, so I just combine them. 6 plus 1 is 7 now. It's not there anymore. I added them up when you multiply, right? Right, guys? Okay, making sure. Don't scare me, please. All right, whenever you have a power to a power, and I don't want you guys to be a robot, so I'm going to tell you why. Whenever you have a power raised to a power, or an exponent to an exponent, you're going to multiply those powers. So this is z to the 7 over 28, which I know 7 over 28 reduces. How many times does 7 go into 28? So this is z to the 1/4. And I'm going to explain right now in a little bit. So do another side note. Where do I got space? I got space here. So when you guys were in Algebra 2, or probably Algebra 1 probably, x squared to the 3rd power. Remember what that 3 means? That 3 means that you got 3 of them. X squared, x squared, x squared. Because I don't want you guys to be a robot. Now check it out. That x squared means x times x, x times x, x times x. Do you guys see that? How many x's do you see? So that's x to the 6. So from there, you can say, oh, okay, if it's a power raised to a power, I can just multiply that. Do you see how we did it? So that's how they derived it, hopefully, in Algebra 1 or Algebra 2. And there it is. So I did the same concept. I had x to the 7th, z to the 7th, raised to the 1/28. Oh, what do you do now? Multiply those two dudes. You get 7 over 28. Yeah, you can leave it like that, but it's not normal. If you can reduce it, it's not normal for you to leave it like that. So 7 goes into 28 4 times, so z to the 1/4. So now, I got to look. Which one of these is z to the 1/4? Yeah, D, guys. Remember the 4th, the denominator, was your root number. Cool or not cool? Yeah, see, so hopefully your ACT scores are going up. Do you guys, is this good stuff or no? Okay, because I don't want to waste y'all's time, guys. So here we go. So this one here, what am I going to do first? I'm going to evaluate the inside. So, x to the 4th times x. What is that? X to the negative 3. Good job. And I have it raised to the 5, 6. I guess we can go ahead and just multiply these two dudes. So if you go to here to the side, 3 times 5, 6. I know it's negative, so there it is. 3 goes into 6 twice. So I'm going to see x to the negative 5 halves. Are we all right so far? Is anyone confused with how we got here? What's up?
I don't know what separation is.
Oh, well, first I did the power rule for the top. Whenever you have exponents being multiplied, you can just add them up. So negative 4 plus 1 is negative 3. So then I got that x to the negative 3. And then I use the rules that I just talked about right now. I have a power raised to a power. So when you have a power raised to a power, you just multiply it. You know what I mean? So when you multiply negative 3 times 5, 6, it reduces to negative 5 halves. All right, now from there, one of these is that same thing. So that negative power means this, 1 over x to the 5 halves. And now that 2 means square root, right? And the 5 means power, so which one is it? No, not A. They tricked you. I think it's B. What do you guys think? No, it's all good. There's a safe space. We're good. Cool or not cool, guys? Yay. Hopefully you guys are happy. Let's keep going. And this one always tricks someone. It even tricks some of our calculus kids sometimes. So check it out. What do you think, V, kind of on this one? So you see this x to the negative 3/5? I'm going to bring that up. The 2 stays in the bottom, guys. The 2 stays in the bottom. We always trick someone with that. So now, what does that mean? 5th root of x cubed with the 2 in the bottom. They could have also written half in the front. So we look for that answer. And that answer is perfect. C. How do we feel? Do we feel okay? Okay, make sure to hold on to these because we have a little activity in a little bit. All right. Try to do as much as you can without a calculator. If you're going to use a calculator in a little bit, you can use the delta calculator. So it says simplify 36 to the 1/4 in simplest radical form. So what does that 1/4 mean? The 4th root, that's it. And I know you're thinking like maybe we can reduce this. Nah, it doesn't reduce. That's it. I mean, I know the square root of 36 is 6, but then 6 doesn't reduce like to a nice, yeah, you can get 3 times 2, but remember I'm trying to get groups of 4. Does that make sense? So it doesn't reduce, leave it alone right there. How do we feel? Awesome. But this one here, this one I like a lot. So check it out. 81 to the 1/4. Let's go ahead and multiply those two dudes out. 81 to the 5/4 equals, this is actually a very common problem in let's just do it. 4th root 81 to the 5th power. Are we okay so far? All right, I'm going to use my definition. Guys. This says 4th root here, and I have 5 of these. So check it out. 81 times 81 times 81 times 81. 1, 2, 3, 4 times 81. Because it says 4th root, I'm going to group 4 of them. And by the definition, I'm going to take that out. Does that make sense to you guys? So right now I have 81, because there's all 4 of them turn to 1. 4th root, and I have how many left? 1 more, 81. Now here comes the beauty part. I'm going to wait because this is going to be so awesome. See, math is all about patterns. I would hope, and it's okay if you don't see it, but I would hope that there's something in your head saying, oh man, the square root of 81 is 9, and this it's so fishy. Well, yeah, you guys are right. The square root of 81 is 9, and notice that 9, isn't 9 a perfect square root? So check it out. This, the square root of 81, or the fourth root of 81, sorry, is the same thing as saying 3 times 3 times 3 times 3. Do you guys see that? Because 3 times 3 is 9, and then 3 times 3 is another 9. And is there 4 3s right there? So that means this whole shebang, that guy, that dude right there, is nothing more than 81 times 3. And I think we can do that without a calculator. I don't know, because sometimes we're really tired. Let's see. 8 times 3 is 24. So that means 80 times 3 is 240. And then just add another 1 because it's 81, not 80, right? So this should equal 243. Do you see how we did it? Yeah. Now, there have been moments where I've been so tired that I said a completely different number. But right now, I think I can think pretty good, at the moment at least. How do we feel? Cool. Do we have just one left? Oh, we just got, just 3 left. That's it, guys. Just 3 left and we're done. Well, then you got to finish your delta. But don't worry, we're going to make it worth it for you guys. All right, so here we go. So simplify all this stuff. So I think the easiest way for you guys, is to go ahead and use your law of exponents immediately. So apply this negative 1/3 to all of them. Remember that 8 is like 8 to the power 1. So I'm going to go 8 to the power negative 1/3. X to the power, what is 3 times negative 1/3? Negative 1, good. And then what is 21 times negative 1/3? Just say, how many times does 3 go into 21? Does it go 7? So y to the negative 7. Do you guys see that? All right, so what does that mean? That means 1 over 8 to the 1/3 x y to the 7th. Are we still okay? All right, let me write what that 1/3 means again. 1 over 3rd root of 8 x y to the 7th. Does 8 have a perfect 3rd root? Yeah, what is it? 2. And you can use a calculator, but try not to. 1 over 2 x y to the 7th. What do you guys think? Cool, right? And there it is. Those questions are actually, these right here, are very popular on the SAT, ACT. Bless you. They're very popular in the SAT, ACT. So hopefully now you feel the confidence to conquer all of those. All right, let's go to this one. They're supposed to be getting harder, but I don't really see them as getting like extreme. I would just apply the rules right off the bat. So I'm going to go 16. Remember, that's 16 to the power 1, so it's 16 to the 5/4. X to the 25 over 4. Are we still okay? And then I'm just going to apply my rules. So let's see. The 4th root of 16 to the 5th times the 4th root of x to the 25. Yes, I could have done it all in one radical, or all in one 4th root, but I decided to separate it. Are we okay so far, guys? All right, here we go. I'm going to use my rules. 16 times 16 times 16 times 16 times 16. 1, 2, 3, 4. So that means for sure I have 16 on the outside. And then I'm going to have the 4th root of 16. I'm just simplifying this. By the way, that hopefully something's going on. 2, 2, 2. Yeah, it's going to work. Times, let's see, there's 25 of those. I'm not going to write 25, a whole of those things. So here's how I'm going to do it. Hopefully we can do it really quick. Give me 4 does not go into 25, but give me a number lower than 25 that 4 does go into. 24. So can I write x to the 24th times x? Okay. Now, if I were to split this up into groups of 4, x times x times x times x, and I were to do it again, that's one group. X times x times x times x. There's another group. How many groups of 4 can I get? Yeah, how'd you do that so quick? Yeah, 4 goes into 24 6 times. You're living the math life, miss. Good job. So now I can say that this guy right here is nothing more than x to the 6th fourth root of x. Do you see how we did that? Because you every time you got a pair of x's, you got it out. X times x times x. Cool? So this is going to be x to the 6th fourth root of x. One last thing. Oh, I feel like Apple, like the Apple CEO. One last thing. Okay. What is the fourth root of 16? The fourth root of 16. Can you think of a number? Is it a perfect root? Not 4. 2. 2 times 2 times 2 times 2. If you're having an issue, you can use the calculator and get it there. So what is 16 times 2? 32. X to the 6th fourth root of x. There's my answer. Because the way they wanted it. Let me zoom out. They said simplest radical form, so they want to see a radical. And the smallest possible number in there. It turned to 32 because of this guy right here. 16 times 2 was 32. Does that make sense or not?
Oh,
Yeah, no, it's okay, miss. This guy right here is a 2. So remember, this is all being multiplied. So 16 times 2 was 32. You know what I mean? How do we feel, guys? Awesome. All right, let's do this one here. So now we're getting into kind of big numbers, kind of. 125 to the 5/3 times x to the 5/3. All right, let's see what that means. Third root of 125 to the 5th power times third root of x to the 5th power. Oh, I don't know. We'll see if we can do it. All right, so that 5 means that I got 5 of these. 125 times 125 times 125. 1, 2, 3, 4, 5. We're going to take 3 of them. So I'm going to put 125 on the outside. And I still have 2 left. And hopefully there's stuff ringing, but we'll see if we get there. And then this one here, there's nothing you can do about this guy. Well, I mean, I guess there is something, but it's not like awesome. Third root, x to the 3rd times x squared, right? Oh, sorry. X to the 3rd times, yeah, that's it. Actually, that's it. Times x squared. Some of you guys gave me a weird look, and I thought I was wrong, but we're good. Are we okay so far? All right. Did I mess anyone up? Okay. So check it out. On this one, I guess that's the only one you can take out. So I'm going to have x and then cube root of x squared. And the x's don't simplify anymore, so you're done with those. Check mark on that. Cool? Now, I don't know if you know, but I think 125 is a perfect cube root. Right? How do I get 125? I know this is 125 squared. Yeah, 5 times 5 times 5. 5 times 5 is 25. And if you have 5 quarters, that's $1.25. So 5 times 5 times 5, that takes care of the first 125. And then 5 times 5 times 5, that takes care of the second 125. Do you guys see that? So now, this is 5, this is 5. Ooh, let's see if we can do all that multiplication. 125 times 25. I don't know what that is. X cube root of x squared. If I have 125 quarters, how much money do I have? Yeah, hook me up. Tell me what I got. So what is 41.25? 41.25. 4,125 x cube root of x squared. That's the simplest you can get in radical form. Oh man. 3,000. 3125, yeah. How do we feel?